Hi guys, welcome back to the channel. Uh, moving next to the sliding window list, we'll be doing the next problem and we'll leave the rest because we don't have enough time to complete all the lead code problems. So we'll go for the next type of problems like binary search, greedy and all. Not greedy, binary search, trees, tries, and graphs, DFS, BFS, and all. So the problem is lead code 1052 grumpy bookstore owner. Okay, there is a bookstore owner that has a store open for n minutes. So there is a bookstore owner that has a store open for n minutes. There are given sorry you are given an integer array customers. Okay, we have an integer array of length n where elements in the number of customers that enter the sorry where element is the number of customers that enter the store at the start of ith minute. Okay, so uh, there will be like from starting from 0th minute to nth minute, each element represents the number of customers that stepped into the store. And all those customers leave after the end of that minute. Fine. So customers will be staying there for a minute. Okay, during certain minutes the bookstore owner is grumpy. You are given a binary array grumpy where element is 1 if the bookstore owner is grumpy during the ith minute and is 0 otherwise it is grumpy. Wait a minute. Okay, what's grumpy? Okay, bad temper and irritable. Fine. During certain minutes the bookstore owner is grumpy. You are given a binary array grumpy where element is 1 if the bookstore owner is grumpy during the ith minute and is 0 otherwise. Okay, fine. When the bookstore owner is grumpy, the customers entering during that minute are not satisfied, otherwise they are satisfied. Okay, the bookstore owner knows a secret technique to remain not grumpy for minutes, consecutive minutes. For okay, so minutes is an integer. Okay, for minutes consecutive minutes, but this technique can only be used once. Okay, return the maximum number of customers that can be satisfied through the day. Sorry, throughout the day. Fine. So, so in we have to check a window of size minutes where we can get the maximum number of customers and where the grumpiness is 1. So let's see. So at one's position he is not grumpy. I mean, there is one customer with which he is not grumpy, and the second one there are no customers. And one he is not grumpy. That's fine. So two customers and two he'll be grumpy and one he won't be. So three for sure and one for one. So grumpy, seven not grumpy. So 10. Now we have 10 satisfied customers and 5 he will be grumpy. So where can we use the 3 consecutive minutes? In the window of this, because this will give us the maximum value, which will be 6 for both the ones. So what we have to do, initially we have to add up all the non-grumpy moments, and we'll be sliding a window of size 3 to find the maximum not selected grumpy area. So for select this, and let's also check the constants here. The constants is okay. The customers and grumpy length will be same, and minutes will be between minutes and length of the customers will be between 1 and 2 into 10 to the power of 4, and the number of customers will be either 0 or 1000 at that particular minute. Okay, and the elements in the grumpy will be 0 or 1 because it's a binary array. So let's do it. First, what should we do? Shall we check the window? Uh, let's do one thing. Let's do the both. So I think we don't need another variable. If this sorry, if we see I we should convert 0 to 1 and 1 to 0 in order for a better way to do things. 1 minus grumpy of I. Grumpy of I. So for in the window we have to remove the grumpy part, right? How do we do it? One, two, window sum. I find range of window sum equals 0. Window sum plus equals to unsatisfied will be the sum until that point. This grumpy total. In the window we have to find the, let's don't make it complex, let's just do one thing. So we have added all the grumpy moments, and let's see all non-grumpy moments. Sorry, all we have added all the non-grumpy moments here, and let's add all the maximum of the, sorry, window size. It should not be window size. It should be max gram max grumpy will be 0. So max grumpy equals to, so 1, 2, and 3 are, and I'll call it as 0. Let's fill it later. Let's now check how do we add this. If or minus one or this one is or minus plus one is 3 is minutes. Then what should we do? That means we have the proper window size. We have to add the grumpy moments, right? Let's keep a temporary variable which will do is equals to so here we are adding all non-grumpy moments. Here grumpy moments within the window, so it will add up all the grumpy moments. And if the window size is reached, then what are we gonna do? Now we shall return max satisfied plus max grumpy. Let's see if it works, and if not, let's debug it. No, let's see what went wrong. Max grumpy or satisfied. So our max grumpy went bad. So how do we reset it? Let's debug the thing properly. So temp minus. Let's print it out and check what's going wrong. So initially temp is 0 and I is right. Right. I understood. So this is where we went wrong, guys. It's a silly mistake. It should be or not I. Let's see now how it is going. So did we print satisfied and max grump? Let's see how different it is. So it is 10 and 5. It seems it should be 10 and 6. So what can we do? Let's check the debugged version. So initially R and temp are 0. So it's 0 itself, and later it's R is 1 and temp is 0. 2 0. 2 0. I didn't get it. Right. So 0 customers, right? So this whole thing here will be 0, and in the next window size it will be 0 into 1, 1 into 0 is 0, and 2 into 1 will be 2. So we got 2. 2 is fine here. And later temp is 3. 1 2 1, right? 1 2 1. So 2, it's fine here. And let's also, why not, let's also check cal value to check if it is going as we planned or not. It will give a proper debugged version, right? So L0 01 is fine, 02 is fine, 13 fine, 24 35 46 57. Now let's see the grumpy, maxi grumpy. So the temp, right? Let's see the temp. Temp is 0. It's fine. It will be 0 for the whole window. So let's move to the 1 3. So from 1 to 3, the temp will be 2. So the temp become 2, and 2 to 4. I think we should keep it greater than, right? So from 1 to 3, it's 2, and 2 to 4, it's 2, 3 to 5, it's 3, 4 to 6, it's 1, 5 to 7 is 6, 10 to 7, 16. So it seems working fine. Let's, uh, what should we do? Shall we add another test case, or shall we submit it just like this? Let's add another test case, right? Okay. So this whole window, it should not be considered because, sorry. Let's take this out and let's see if we are getting the proper answer. 18. How's that? Alright. Since it is considered okay, then maybe this will be the window we have to consider. Or no, not that. This one. 2 plus 1 will be 3, and 1 into, I mean, 1, 2, 9, 9 plus 5, 14, 1, 2, 3, 10, 15, and this 2 and 1 will make our choice better, which gives us 3. So total 18. So let's submit it and we'll discuss the intuition. Okay, guys. It's working great. And let's see if there are any best solutions out there other than the one we did. I think these two can be kept inside a single loop because both of them are iterating over a loop of size I. So let's, initially why we didn't consider that, because it is making our problem complex. So let's bring it here. Let's keep this side R. heartbeat. Or let's add a comment too. So here valid satisfied moments hacked satisfied moments, because why hacked satisfied moments? Because our grumpy grandpa is uh, following a routine, I mean following some secret technique to the customer. So yeah, so he knows a secret technique to stay not grumpy for few minutes. So let's see. Let's try submitting it and check if we go any further in time complexity. Hmm? Ta-da! We were. I just. I just don't understand what's wrong with this. Mm, Let's see if there are any better approaches other than ours. So if grumpy is one, grumpy score satisfied equals to, okay. Grumpy score minus customer five. Minus L plus one. Grumpy of L. Whatever. We are not doing a huge computation. I think I know why we are at the last, because of this multiplication. So it goes like this. Multiplication takes more time than addition. So here there is no multiplication going on, and that's why it is going fine. But so let's discuss our approach and then see the others. So what we are doing, uh, we are maintaining uh, satisfied, like we are calculating all the satisfied customers, valid satisfied customers actually, and we are counting maximum grumpy uh, window where he could use the secret technique to gain maximum customers attention. So here we are adding uh, grumpy time, multiplying it one gives only one, right? So I don't understand. Anyway, we can do it better if we keep it equal to equal first it right. Sorry. You should not keep it like this. It will cause so much havoc. Let's do it. If Grumpy of L, sorry, it should be R. Now it will be fine. Let's see if it goes faster than 27%. Ah, since we screwed it, we can stay on Grumpy for 1 minute. Grumpy of okay, Armands. Okay. So let's just use ours and let me explain how we approach the problem and what we did. So we are looping through the the range of customers. Since the range of customers and the range of Grumpy, I mean length of Grumpy and length of customers will be same. So we are adding all uh, non-Grumpy moments. So if Grumpy of R is 1, then this whole thing will be 0, which will add 0. And if Grumpy of R is 0, then it will be 1. So 1 into customer of R will be added to the satisfied customers. And if R minus 1 plus, okay, so if the window size is greater than uh, the minutes we want, then we are removing we are reducing the left index, I mean left bound. Since we are increasing the left bound, we are decreasing the health value from temp. As we increase the earth value or right bound, we are adding uh, all grumpy moments and recording the max grumpy moment of them all. And so the window at which we get maximum grumpy will be added to all valid satisfied scenarios, which will give us the answer. So in this case, what he or she, anyone, what this guy or this person did is he go through the length of grumpy, which is same as customers, and if grumpy of I, okay, okay, so he is adding up the grumpy score. If it is not grumpy, he is adding it to the satisfied customers and checking the window size. If the window size is greater than minutes, like just like ours, um, if the moment is grumpy moment, then we are reducing the moment, and max score. So what? Let's make it if grumpy of r is 1, else which are non-grumpy moments. So I'll add comment 2, adding non-grumpy moment, adding grumpy moments. Now we don't need to multiply it, we can directly add it as it is, and if r minus, okay, is a grumpy moment, then we will reduce it from the 10. Oh, sorry. Let's see if it goes greater than 26%, 27%. It surely seems because we are not using multiplication. The thing is, I even don't know initially that multiplication would cost so much time than addition. So let's see if it is true or not, and what extent it's true. Okay, it seems it is true, but it won't be that significant. Uh, okay, if we can manage with addition, uh, we shall do it with addition. So guys, here is the solution. So I hope you guys understand. We are adding all grumpy moments and grumpy moments to temp and non-grumpy moments to satisfied. And if the window size exceeds, then we are increasing the left bound and decreasing the non-grumpy moment from the temp. Sorry, decreasing the grumpy moment from the temp. And in the along the way, we are recording the maximum grumpy window, and finally we are adding the maximum grumpy positions that can be hacked and all the satisfied valid positions. Okay guys, I hope you guys understand, and keep pushing hard, keep learning. We'll meet you in the next video. Bye guys.